is allowed to do on the website or anything that allows for extra complexity for our database. In the last couple of videos, we've talked about all of the characteristics of keys in general. We talked about the word key. In databasing, keys are the key to success. Anyways, this video we're going to be talking about specific kind of keys. Because all of the last videos were kind of concepts, but now we're going to be talking how do we actually implement that into a database. I understand that we want keys and we want references from table to table and we want it all to be connected, but how do I do that? Well, the main two types of keys that you're going to hear are known as primary and foreign. And actually, we're not going to be talking about these two kinds of keys in this video. Surprise! We're going to be going a little bit broad, a little bit more broad. So when you're like a beginner and you're learning database design, you'll probably learn that these are the two kinds of keys. When you want to learn more advanced database design, you'll learn about different categories of keys. So before we get into these two, which if you guys haven't heard of those, just hold up. If you have heard of those, keep holding up. We're going to be learning about what's known as a super key. Now, for some reason, I think this is one word with no space, and I don't know why there's no space there. So if someone knows, if like one of you guys watching know, let me know, because I really want to know. It's driving me crazy. The other one that we're going to be learning is candidate key. Alright, so before we learn about the candidate key, let's just focus on the super key. So I'm just going to erase this. Alright. So what is a super key? Well, a super key is any number of columns that forces every row to be unique. Now, if for some reason your table is structured to where you can't have every single row be unique, you need to consider adding some kind of column to enforce uniqueness, such as an ID, or you need to make sure that everyone using the database understands how that table works if it's a special case. But generally, every table you will be able to make unique. Now, when you work with databases, you'll often see IDs, so like user ID. This is a type of key. Then you also will sometimes find keys such as like username. The difference between these is that this one's kind of just made up for the sake of the database. User ID of 748. What does that mean? Absolutely nothing. It's just a number. Username actually has some real-world connection. We'll be getting into the difference between these in an upcoming video and which one will be best to use for which situations. But as for now, we'll just be using kind of natural, practical columns that are already in the database rather than IDs. But the same thing can apply with just like an ID field or a column. So let's learn about the super key. Super key. It's like Superman, but it's a key. Just like a giant key that just goes and breaks through doors. It doesn't even use the handle, it just breaks through doors. Anyways, let's learn. Okay, let's say we have a table here. Big table, right? Now I'm going to put some columns in this table. That is not straight enough for me. Close enough. Now it just looks worse. Whatever. Let's say we have a user table, just because I always think that's the absolute easiest thing to use. And we're going to have a username, email, password. Then we're going to have first name, middle name, last name, and then we'll have birth date. So every single row within this table is going to need a value for each one of these columns. I know this is really bad handwriting, but it doesn't really matter how it looks. Just understand the concept. There, now it looks a lot better, I know. You're welcome. Now you can actually understand what's going on. Okay. Some instances for databases, you will allow people to put in blank values. So for example, if someone doesn't have an email, for example, we could make it optional. That way some people have null or no value at all, other people have values. But for this case, I'm going to say everything is required because let's say you use your email to sign in or to verify your account. Dang it, I always drop my chalk. How do we make sure that every single row is talking about one entity and every single entity only has one row? Everything is unique. If we have a person, I'll draw a little guy over here, right? And he wants to sign up for this website, so he goes to this website, here's this website, he puts his information in, and that information goes into a table, right? He probably won't actually have access to the SQL, because if just some random user on your website has access to your database, kind of got some security problems. But anyways, what's going to happen is he will be entered into this, and all of his values will be put into these value spots. So we have a username, make it CC, email, cc@blah-blah-blah.com, pass is pi, first name is Caleb, middle name Daniel, last name Curry, birth date 02/13/90. So this guy inserted all that information within this database. And if you can't read it, doesn't really matter. Now, when another guy comes, or let's say a gal, so this lady comes and she's all like, oh, I want to sign up for this website. So she signs up for this website. And she puts her information in. And this also goes in the database as a new row. So this is just the column headers. This is separate from the actual data. The rows, though, they have individual values. She can put her values in. I'm not going to write them all out because you guys get the point. How do we know that each individual row is unique and that talks about one individual entity, in this case a user? Typically whatever the entity is what the table is titled, so the entity would be the user. How do we know that every single row is talking about only one user, and every user only has one row, the rule of one? We don't want Caleb to be able to come in here, create a new account, and make his username CC and all the same stuff again. Now in some instances we may be able to allow them to make more than one account, like I could make an extra YouTube account if I really wanted to. That would be okay, so I could have the same, a different username, a different email, same password, same first name, same middle name, same last name, and the same birth date. The only thing that changed is a username and email. Now, what the table is trying to define has kind of changed. We're no longer trying to define the person, we're trying to define the user account. Because now there's two accounts and then they're completely separate entities. Hopefully that kind of makes sense. But you don't really need to worry about all the specifics. I'm getting completely off topic. So what were we talking about 10 minutes ago? I think we were talking about super keys. It's any number of columns that forces every single row to be unique. If you take all of this information and compare it with another, let's create a new row. Let's say this lady here actually ended up putting her information in. Her username is A, her email is B, password C, first name is Hi, middle name is Yo, and her last name is Hello, and she was born 03/16/72. That is her birth date. Well, now, if you compare these values, they're different. Not every single individual value has to be different. For example, this girl's last name could be Curry, and that'd be perfectly okay. But all of the values as a whole have to be different. So if, for example, someone came in here and put all of this information up here, down here, CC at blah blah blah, pi, Caleb, Daniel, Curry, 02/13/90, that is not a unique row and it would cause an error. So the super key could be all of these columns right here. Now, super keys are usually not defined within the database. That's because they're so broad. You have all this information, of course it's going to be unique, simply because you can only use a username one time. Typically the email is only one time. So if someone comes down here and tries the username CC, well then you already got an error, it's not going to work. So all this extra columns right here, kind of unnecessary, because we could simply do that same thing with just the username. So a super key is any number of columns that creates a unique row, unique rows. A candidate key is the least number of columns. Where did I write that? Can you see down here? Yeah, okay, we're good. So a candidate, I'll explain why it's called a candidate in a second, or in the next video or something. A candidate key is the least number of columns. So for this example, we're not going to allow two people to have the same username. We may allow them to have the same email. We may allow them to have the same password, first name, middle name, last name, and birthday, but not the same username. Because then how do you tell them apart? You can't, because all of their information is the same. They're exact clones to the database. And we do not ever want that within our database, typically. I mean, I can't really think of any examples where you would want duplicate data. But okay, anyways, the candidate key is the least number of columns needed to force every row to be unique. In this example, the username is enough to make it unique. So we can take the candidate key and have it to be just the username, or I guess we could circle the column, because all throughout the rows are going to be unique. So the candidate is least, and super key is any. Alright, now when it comes to database programming, let me clear this up so your brain doesn't explode anymore. It takes forever. I'm on a time limit here, guys. People are going to stop watching. Alright, now that I just got my chalkboard to listen to me and erase the stuff. When we're talking about database programming, there's not really a time where we're ever going to tell your database that this is a super key, because super keys are not practical. They are for designing your database only. When I looked at that column, first thing I do is I think, super key, yes, every single row can be unique. That's the first check. So you ask, can each row be unique? That's the question. That's to define, that's what the super key is questioning. Can each row be unique? And even better word, can every row be unique? Because every single row within a table has to be unique. That's what the super key is asking. Once we figure that out, if it can be unique, then we move on to figuring out the candidate key. So now we ask, how many columns are needed? Can you read that? Hopefully. So the first question, can every row be unique? Yes, that means we have a super key. That's all we have to worry about. We don't have to figure out which columns or anything like that. Can every row be unique? Always. Think about all the possible values. Is it possible for a duplicate? If it is, you got to figure something out. If it's not, you're good. So every row can be unique? Yes. Check. Move on. How many columns are needed? Now you figure out the least number of columns needed in order to create unlimited uniqueness forever. So no possibility of uniqueness. And we are allowed to put some kind of like limitations. We can put a unique, we can use the word, it might be different for different relational databases, but if we use a unique index, for example, every single column, every single value within a column has to be unique, and that's a requirement for people to put in. So if it's not unique, we give it an error. That's how we force values to be unique. So how many columns are needed? Once we figure that out, we have what's known as a candidate key. So in the last example, it was just one because we could use the username. Now, the next thing I like to figure out is how many candidate keys do I have? I'm just going to use CK for candidate keys. How many CK do I have? What does this mean? Well, we can actually have more than one candidate key. In the last example, we had a username. We also had an email. Okay? Well, email could also work as a candidate key because you could put a requirement that every account has a unique email. Some websites are cool with people using the same email more than once. Some websites aren't. Usually they're not. So there might be a chance where we have more than one candidate key. Or if rather than using the username, you want to use something else, you could have it to where we could have, let's say you can use your email more than once, we could have first name plus last name plus middle name, or middle initial. So that eliminates most possibilities of uniqueness. But there's still a possibility that people have the same name. So then you add birthday. So now you have to find someone with the same first name, last name, middle name, and the birthday. Very rare, still possible. So then we could add a third, I guess 1, 2, 3, a fifth column. We could make it email. Or we could do something such as address. Alright, let's go with address. This could be a candidate key because we have first name, last name, middle name, birthday, and address. They all have to be unique as a whole. What are the chances of a person living at a certain location, born on a certain day? Also, what are the chances of two people having the same name, same birthday, and living at the same place? Unless you had twins and you named them the same thing, and if that's the case, shame on you. I'm just going to confuse people. That could be a candidate key. Now, is it the best candidate key? Probably not, because we're using 5 columns, and it's still technically possible to have a duplicate, but very, very, very rare. Alright, so how many candidate keys do I have? You figure them out. I like to write out the possible candidate keys, and then we move on to the next step, which is defining the key that we will use for our table. Once we have the candidate keys, we can choose one of them. They're called candidate because there's an options. Like you could have your first candidate key. You could have candidate key 1. You could have candidate key 2, and then you could have candidate key 3. This could be the username. This could be the email. This could be that long first name, last name, password, blah blah blah, or whatever you really want it to be. Now you have to decide which one will be your primary key. We're going to be picking up from where we stopped last video, which we were talking about candidate keys. So this video, we're going to be talking about primary keys, which is the next step. So what is a primary key? Well, in the last video, we defined some possibilities for candidate keys. Something we could use as the main key. It's a candidate because we have to pick it to be our primary key. So we have a list of possibilities. One of them was a username. Another was an email. And then if you don't have something simple like this, you could do something like your full name, which that would be like first name, last name, middle name, and then plus an address, which address would probably be broken up into like street, city, all the parts of an address, and then possibly your birth date, or just Dob. So here are just some possibilities for candidate keys. We could have a username, email, first name, middle name, blah, blah, blah. Well now, once you have all your possible candidate keys, you want to pick one to be your primary key. So how do you do that? Well, once again, you got to make sure we look at the rules or suggestions for keys. This is specifically talking about primary keys. We want our primary key to be unique, never changing, and never null. So username is never going to change, right? So, that's pretty good. You always need a username when you sign up for an account, so it's never null. And it has to be unique because two people can't have the same username. So this would be a good primary key. Let's check out email. Well, you can make it unique. You can require people to only have, like you can prevent multiple emails. So when you create an account, you can only use an email that has not been used. That's an option. So that's possible. Never changing. Well, it depends. Depends on if you use your email like a user account username, like you sign in with your email and you have a password too. Well, then the chances are you're not going to be able to change it. Although now you can probably update your email and stuff. So it's possible to be never changing if you prevent people from updating their main email. So possible, and never null. You can require someone to have an email. So that's possible. All three of these are possible. So this is possible. I'll just put a dash. First name, last name, middle name, address, date of birth. Well, probably the whole group as a whole will be unique. The chances of finding someone with your same name, living at the same place as you, with the same date of birth is almost impossible. So, unique, practically yes. But possible, you can possibly have a duplicate. So, possible. Never changing. Oh, well, people can get married, so their last name can change. First name can even change, or middle name can even change. You can move. You can't be born a different date. I mean, you can't be born again, like, unless you become a Christian. But anyways, never null. Well, some people might not have an address. Either that, or they might not have a middle name, or something like that. So, this is probably not the best primary key. So, in this example, I'd probably go with the username. And then, you define that as your primary key, and then you can use that to make connections between tables. So you have a comment by a username. That's the connection. That is a natural key, and we'll be talking about surrogate keys in the next video if you know anything about that. But basically, you can use your username as an ID, rather like as a primary key. So you could have, let's say this is my username. This can be the connection for all of my rows by me. So if I have a table for comments, a table for users, a table for sales, well, if I buy something, Caleb Curry, connection. If I'm a user, well, connection. If I post a comment, connection. It all kind of points back to the user table because that's going to be the parent of the relationship here. So this could be a primary key. So that's a primary key. Now this will also be indexed because primary key is a type of index. So you can do select statements really easily with that and everything like that. So that's going to be how you connect most of your data. Now, the other candidate keys that we did not choose, they're known as alternate keys. An alternate key, it works. I mean, it could be the primary key, but basically it's all the candidate keys that were not selected as the primary key. You're not required to define all of your alternate keys in your database. In fact, you don't even need any alternate keys. But you may want to because oftentimes they will be something you're doing searches for or connecting tables or whatever it is. Alternate keys might be useful. So you can create an index on the alternate key. So I could create an index on the emails, for example, because I said that was a possibility. Well, now that'll be an index, and it will probably be used because you might want to do data by the emails, like selecting everyone by their email. You know what I mean? Maybe, possibly. Basically, you can do a select, and then you can choose the columns you want to choose, and then the table, and then you can say where, and then you could say like email has the value legit at awesome.com. Because you have an index on that, it's going to work better. So if you have a really good alternate key, I recommend you index it simply for good design, and it'll help your database run faster. But if you don't really want an index on it, then don't do it, because that's just another thing your database is going to have to maintain. It's going to have to update the index as well as the book. Sort of how if I have a book here and I change the insides of the book, well then the index in the back is going to have to change too. So alternate keys, you can set them as an index if they are good and useful, if you will be searching for that kind of information. So that is introduction to primary keys and alternate keys. So we got I think I'm spelling this right, by the way. Surrogate, and then we have a natural. Alright. So we talked about primary keys in the last video. That's as far as we'll get for defining a key. These are categories of primary keys. So we define a primary key, and then this is just kind of like a descriptive term. We don't have to define in our database surrogate primary key or natural primary key. This is more for database design, to know like the difference between types of keys. Hopefully that makes clear sense. And if not, just stick with me. Alright. Okay, so up to like all these key videos I've been doing, I've been using natural keys. Let's define a natural key first. It's a very natural definition. It's something that's naturally in the table, something you naturally want to store. When you have a users table, you naturally want to store the username and the email. Those can be used as natural keys because they fit all the requirements for a primary key, and it's already in there. You don't have to make up something. You don't have to think of a column to add just for the sake of having a key. We want to be able to have a key for every single table, but sometimes the natural key is not very obvious or not so natural. So we want to try to find a natural key when we're using natural keys. Generally, when you create a database, so let's say this huge box is our database. Within this database we have a bunch of tables, and then within each table we have a bunch of columns and rows. See what I'm saying? Well, these are all connected in some funky way with relationships. Well, when we define a database, typically, I mean maybe not always, we want to try to either always use natural keys or always use surrogate keys, which are just made up keys. We don't want to kind of flip-flop, switch, and I can't think of any other words, because we want to try to keep it consistent. Otherwise, people using the database are going to be confused. Is this a natural key or is this a surrogate key? Is this something that actually has real-world value, or is it just a made-up number? So, let's say we are using natural keys. There are a couple problems with natural keys, and this video will be explaining the difference between these two, and then the next video will be talking about pros and cons of each, basically. So natural keys are what's naturally already in the table, something we wanted to store to begin with, right? The thing is, they have real-world value, so your database might adapt, and the meaning of your keys kind of adapt too, which, once again, I'll explain that all in the next video. Surrogate keys, they are a column that's just added to your database, no matter what, even if you have a good natural key, because remember you want to either use all natural or all surrogate, usually. So if I decide to use surrogate keys, I'm going to give an ID to every single row within every single table. So we have, let's say we have a user table, and then we have a sale table, and then we have a comment table. What we do is we give every single table an ID column. So we have a user ID column in the user table. We have a sale ID column in the sale table. We have a comment ID in the comment table. So now when we have, let's look at the comment table in depth. We have the comments. We're going to have a column. We're going to have a column for the comment ID. And then we'll need a reference to the user that posted the comment. So we'll have the user ID as a foreign key, which points back to the user table. So that's kind of how that works. Now we just have random numbers. The ID is just a big number that has a feature known as auto increment. That means every single time you make a new row within this table, it's going to raise the ID by 1. Then when you delete columns or something and you have gaps within your numbers, it doesn't really matter because the number has no real world significance. Typically, surrogate keys are kept completely private. No one knows the surrogate key except for the people working with the database. You're not told your surrogate key. So if I created an account on a website, and then I put my username and my password, and then I go to I sign up, register, and do my email junk, and then I sign in and go to my user settings, it's not going to be user ID equals 45 or whatever. It's going to be private. The reason for that is because the world doesn't have, the number doesn't have real world meaning. Therefore, it's private to the database only. If I started giving that number out to everybody who has one of these IDs, or something like that, or if I started putting it on sales reports, well then I'm giving that number real meaning in the world, and it's starting to become a natural key. So hopefully that kind of makes sense. Natural is something that's already in the database. Surrogate is something we just add. The thing that's kind of cool about surrogate is if you're struggling to find a really good natural key, you can always use a surrogate key. The problem with that is you always want to try to be able to naturally make everything unique. Like in a user table, we have a username. That's going to keep things unique. So even if we use a surrogate key, we can still index this username, and that can be used sort of as if we assign it as a natural key. The only thing is we're making connections between tables using the surrogate key. So for this table, we could have a user ID, and then we could have a user name. For just an example, the user ID would be the surrogate key. This would not be the natural key because we can only have one primary key, and the primary key is going to be the type surrogate. So the user ID is a surrogate key, random number, generated number. The username, we can index it and use it like a natural key with when we search the database and everything, but we're not going to use it to make connections between tables and references with foreign keys. So hopefully that makes things pretty clear. In this video, I wanted to talk about the pros and cons of surrogate or natural keys. So basically, we're going to compare and contrast them here. So over here on the left side, we got surrogate. And then over here on the right side, we got some natural. Alright, we're going to have a little battle here, right? We're going to figure out which one's the best. Let me just box this to keep this out of here. Alright, so what are some good things about natural keys? Alright, well first, one of the first good things about... Oh, that was really weak. One of the first good things about natural keys is that you don't have to define any new data. If you don't remember from the last video, let me just redefine them here. Natural keys are columns used as your key that are already defined within your table. They're natural to what you want to store. Surrogate keys are just kind of added, like a user ID or a car ID or a credit card ID or a comment ID. They're surrogate, they have no real world meaning. So natural, not natural. Get it? Cool. So some good things about natural is you don't actually have to define any new data. any new data. I don't know if you could hear me there or not. I kind of stuttered on that. But anyways, you don't really have to define any new data because it's already within your table, and you can use that as your natural key. So you're required to store less information in your database, so you get smaller data. You have a smaller database, right? So that's one good thing. So what's a downside to natural keys? Well, a downside is that sometimes you're not going to be able to find a really good natural key. Because if you look over here, we want our keys to be unique, never changing, and never empty or null. Well, if we have a natural key, we have to find one that fits all three of these, and it has to be a good one that would make sense to use as a natural key. Like, you might not want to use a combination of 20 columns to make natural key, right? But that's one of the downsides to a natural key, is you have to figure out what natural key to use, and there's not always a great option. Now, optimally, you should have a natural key, or at least something that could be used as a natural key within every table to have the best design to ensure uniqueness, not just by a surrogate key if you use one, but by naturally what's being stored. So, like just an example, if we have a comments table, we could have a comment by a certain user on a certain web page or whatever. And what forces it to be unique? Well, the combination of that, as well as the date it's posted, or the time it's posted, that's going to be unique, because you can't have two comments from the same user at the same time on the same web page. It's not possible, right? I mean, unless you like glitch the system somehow, which shouldn't happen. Well, that's an example of using natural keys. The downside, like I said, you might not always be able to figure out what to use for your natural key. That one was a good example because naturally we could figure out a natural key. Right? Following me? The other thing is natural keys have real-world values, real-world meaning, right? So you have connections to real-world meaning. So, for example, in the comments, the actual comment in combination with the user who posted it, in combination with the time it was posted and the page it was posted on, or any of those 4 columns to be used as a natural key. Well, those have real-world meaning, and as your database develops over time, the database application might change or be updated, or new meaning is given to the database and what it's supposed to do. That means that your natural keys could change over time and have new meaning, or the actual values could change in some instances, and we do not want that, obviously, because it has to be unique, never changing, and never null. If, for example, we make it to where we do have to change the natural keys, well, that would kind of be like crossing this one out. And that's possible, like we could update the values of all the keys, but that's going to require us to update all connections between tables, and that's going to require a lot of resources from our server, and that's just a bad design in general. So those are most of the cons of natural keys. So yeah. Let's move on to surrogate, right? Okay, so surrogate keys. Well, obviously the first downside is you have to add a column to your table no matter what. Even if you have for example, if it's naturally unique, well, you might, like if you have a comment from a username, well, that username is going to help ensure uniqueness, and you still add a surrogate key, well, then you're adding unnecessary data because you're adding a new column and you have to store all these numbers. One of the pros of surrogate keys is that they're typically numbers, where oftentimes natural keys can be words or anything like that. That's good because typically numbers are easier to work with, but not always. Now, a couple other things, besides the fact that you have to add new data, new column, which requires you to store more data, it's that it can be confusing sometimes when all you're working with is just combinations of numbers, and we have a column, let's say like a commenter for a comments table, and we just have we have the value like 7,462. Well, this kind of clear. It's talking about the user with the ID of 7,462. Sometimes columns won't be very descriptive though, and that would be a fault in the designers, so make sure you name your columns right. but when working with other people, you can sometimes get confused exactly what references what, and you have to do a little bit more thinking and check the actual database structure, the way it's programmed, or however else like that. So that's a couple things that are confusing. Okay, so now you're probably wondering, okay, so which one am I supposed to use? Well, it just depends on what you want to do, if you prefer to use natural or surrogate keys. But typically, you'll want to pick one and use that throughout all of the database. I said database really weird there. I was like, database. I was like, database rather than database. I was like, database. Anyways, so let's say I decide to use surrogate keys. Well, that means every column should get a ID, or at least a combination of IDs. Natural, if I decide to use natural, well, that means every column should try to be used as a natural key. Because if we mix and match, sometimes we're going to have a surrogate key, sometimes we're going to have a natural key, and it's going to be super confusing and we're not going to know what's going on. So typically you want to kind of keep one or the other. The other thing is, I don't know what the other thing was, but yeah, typically one or the other. Now for my sake, I personally am going to use surrogate keys, although that's not saying that they're better in any way. I just prefer surrogate keys because it's simple for me, because every time I make a table, all I gotta do is make an ID with the, like if it's a user table, all I gotta do is make a column, user ID, and boom, we're done. That's all I gotta worry about, and I don't really have to worry about it ever changing or it ever becoming something different or anything. It's just a random number, 7,254. Well, that has no real world meaning. Now, keep in mind though that if you do use surrogate keys, you shouldn't have them have any real world value. So for example, a student ID, if we give these student IDs out to the students, that's not really a good idea to use as the surrogate key because it's actually a natural key. It has real world meaning. So those are just some things, and you can find tons and tons of stuff on the internet about natural or surrogate keys. It's basically like a war between two database sides. Oh, we're the natural keys. Oh, we're the surrogate keys. Ah, I'm gonna kill you. Boom! You know what I mean? So yeah. Don't freak out. Just figure out what works best for you. There's some minor performance differences, but I mean, I don't really know all of them. So yeah, believe it or not, I don't know something. I'm kidding. But anyways, try them both out if you want. Look up stuff. Look up which one performs better or which one will work best for your application or your database, because that's really what matters. So this is a big subject and there's a lot of important things. So I'm going to be separating a lot of these concepts up into separate videos. So the next 2 or 3 videos, this video and 2 others I think, will be over foreign keys and a lot of things that have to do with foreign keys. Sorry. Anyways, this video will be talking about introduction to foreign keys and what exactly they do. Alright, so a foreign key is a reference. And what does it reference? It references a primary key. So that's the most basic definition of a foreign key. Now this can be a primary key in the same table or a primary key in a separate table. So let's kind of see how this would play out if we do some drawing, right? Let's think of a class for a college database. So this database has all the information for a specific college or multiple colleges, and one table is for classes. We also have a table for instructors and for users and anything else that's an obvious entity. So let's look at the class table. So we have a class table. We'll just draw it out here. Within here, we could have a class ID, which, like I said, we're just going to be using surrogate keys for most of this. You can do the same thing with natural keys, and if you have no idea what I'm talking about, just pretend I never said anything. So yeah, we have a class ID. That's an example of a surrogate primary key. We could also have an instructor You see? So we can have an instructor ID, right? And we could have, let's say, a room number, because we could have a table for every single room, which talks about more information about the room. Or I don't know if that's a really good example. Or we could say we have a bigger building or a bigger college, and we have a table for each building. So that's probably a better example. So we could say building ID to say which building it is in. All right, so here are 3 IDs. So you can assume that they're all keys, because almost all IDs are going to be keys of some sort. Which one is the primary key? Well, this one right here, the class ID. This is the primary key because it's the class table. Every single row within this table is going to have a class ID, whether it be 1, 2, 3, 4, 7, 12, 843, 64, whatever it is. It's going to have a class ID, every single row. So every single class is going to have its own ID. But we also have an instructor ID, and we also have a building ID. Well, since these are kind of unrelated to the class, you can assume that they're foreign keys in this example, because we're not going to have an instructor ID for a class necessarily by itself. This is going to be an instructor ID for an instructor. So that means we have another table for instructor. So this is our instructors table. I think I'm spelling instructor right. And we have an instructor in here. Instructor ID. Well, this, you can tell that these are a reference here. And we can also have a building ID, so this references another table, and that would be the building. And then we have a building ID. Let me see if I can get this. Sorry, I'm taking forever to write, and I can't even write nice. But that says building ID right there. And this references that there. So you can see there's a connection between these tables. Now we'll get more into drawing relationships better, like rather than just using lines. We'll talk about more of that in the future. But as for now, we can see that these reference these columns. So the columns point to each other, and also each individual row is going to point to each other. So let me explain that a little bit more. When we have a row within our class table, let's draw this table out a little bit better so we can kind of see how it would work. So let's say this is an actual example of the values within this table. We have a class ID, an instructor. I'm just going to put I and then the building ID, just for simplicity. Okay. Dun, 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 dun. Just because I don't feel like writing all that out. So we could have a class ID, and just to make things more, just to be more accurate to what a normal database would be, we could say like the name of the class, like biology or whatever. So we could have a class ID, we could have 7 for a value. We could have the instructor ID could be 63. We could have the building ID of 16, and then the name could be biology. Well, every single column is going to have column rules or requirements. For example, these 2 columns here, individually, this one is going to have a rule that says every single value within this column, so as we go to the next row, the next value, every single one is going to have to reference something from the instructor table because it's an instructor ID. So that's one of the column rules. Now, same for the building ID, we could say that every single row has to reference a value within the building ID. Alright, so that means the row right here, let's say this row individually, this one right here, the class ID with 7, biology, references the instructor with the ID of 63, and the building with the ID of 16. So you can see that the column has rules set to say that every single value within this column, every single row, is going to have to reference an instructor and a building. Now each individual row, we could say, oh, the specific row references the building and 16 and the instructor 63. You see? So that's kind of how foreign keys work. Let me clear this out, kind of draw it out a different way. Let's take a look at the building table. Okay, so let's just draw a little square just to represent it. And let's say within this table, we're not going to structure the columns or anything. We're just going to say we have the building 7, 16, and 14. So these are 3 separate buildings, and we could have names for the buildings and all kinds of other things. Now, we have within the class, let's say this is the class table, right? And we have the class ID, so the class ID would be like 64, 38, 123. It doesn't really matter what number they are. And 8, right? And now we're going to have a reference to the building ID. So let's say we have 7, 7, 7, 14, right? So here's just an example. So over here we got the class ID. We got the building ID. And then we got the building ID. And then we can have more information about the building here if we wanted. Well, you can see that there's a connection between every single value, every single row within this class table has a connection with a building ID. So the entire column, building ID, has the rules that every single value within that column has to point to a value within the building ID of the building table. Now, each individual row has a value that points to a specific row within the building ID. As you can see, these are all individual rows. Sorry, it's getting a little crowded here. We can see that 3 of these classes in this class table reference one building, and that's the building with the ID 7, and that could be the room legit building 74, or whatever you want to call your building. It doesn't really matter. So that's an example of a relationship using foreign keys. Foreign keys are what keep things connected. So let's say the name of building 7 was legit, because I really don't know what else to name it. Well, now we have the value legit as its name, and we connect with the ID. So rather than putting legit, legit, legit and having repeating data that could be easily messed up, for example, if legit was changed to legit with 2 T's, or just change the name completely, well, now with this foreign key, it's connected, so it updates automatically. So, yeah, that's kind of how foreign keys work. Just keep in mind that every table has one primary key. Now that primary key can be a combination of multiple columns if you want, but it only is defined as one primary key. For example, we could have the combination of first name plus last name. This group could be the primary key, but we're not going to have the first name primary key, and we're not going to have also the last name primary key, because that's two primary keys and we can't do that. We can have the combination of the two. But with foreign keys, you can have multiple columns having foreign key relations to different tables. But keep in mind, each column can only have one reference. So in the class example, we had a teacher ID. Well, that teacher ID, here's the class table. And let's say the teacher ID is 7, 6, and 5. Well, this can be a reference, and we could also have another foreign key. We could have the building ID, which could be 6, 12, and 8. So although we are only allowed to have one primary key in a table, we could have multiple foreign keys referencing different tables. If we wanted it to be where the instructor, I think it's supposed to be an I, so the instructor, to where the class can have multiple instructors, well, that's a many-to-many relationship, and we're going to have to redesign our tables with an intermediary table. So hopefully that's kind of making sense. I just want you to realize that the primary keys are what sort each individual tables, the foreign keys are what connect tables, and that you protect that integrity with foreign key constraints, which we'll be talking about in the upcoming next few videos. This video I wanted to talk a little bit more about foreign keys and a characteristic known as not null. Alright, so this keyword here might vary from relational database to relational database, but it's probably something similar to this. Not null, which we learned about null when we talked about this over here. It's basically saying the database will not accept someone not answering that column, for example. So if it's not null, you have to give that column a value, every single row. So the rows are each individual entry within the table. If you have the column characteristic of not null, for every row it's going to be required that it has a value. So think of like a fax number. Does everyone have a fax machine? No, most people don't. So if I set it as not null and I didn't give it a fax number, then it would throw an error and cause problems. That's an example of how not null works. Now this is important when it comes to foreign keys because it has to do with what's known as cardinality, which we'll talk about that when we start designing databases a little more. But it's basically whether or not a relationship is required. So this is going to dictate what kind of values we can put within our table. Back to the fax machine, if we have it to where it's not null, that means every single every single row has to have a value. That also means that if someone doesn't have a value, they might not be able to put any information in this table. So by putting this restriction, you are eliminating all rows that aren't going to have a value. You're preventing them from happening. You see what I mean? Yeah. So if the case is where you do want people who don't have fax machine numbers to be able to enter data into your table, well then you would not want to use not null as a characteristic because that's going to prevent them from doing that. Now this is important when it comes to foreign keys because if we require a relationship, we set it as not null, and that means every foreign key value for that column, every single row is going to have a relationship for that. So one of the biggest differences between primary keys and foreign keys is that primary keys are required all of the time, never changing, never null. Right? Drop my chalk. Dang it! Ah! Alright. Well, foreign keys are a little different because we can have them to where they're not required, they can be empty. Because sometimes that relationship is not there. Or they could update, like we could have a new relationship in this table, which we want to eliminate as much possible updates as possible, but sometimes that's required, and that's why we use foreign keys to keep things connected, so when things are updated, they update across the platform. Now, we don't want the primary key values to change, but we could have the foreign key references change. For example, let's say we have a table over here, alright, and we'll just have it, we'll have it be cars, okay? Or we'll just have it to the car, right? And we have two rows, and we have a car with the ID of 6 and a car with the ID of 10, right? And we have this guy over here, and we have a table for him. We'll just make it the user table. And let's say for some reason we wanted to make a connection of what car he owned. Well, he might currently own 6, right? And we don't ever want the value of 6 to change and still be talking about the same car. Let's say this car is this one over here. This is some flames, right? And this one over here, we got a legit car. Boom, right? So these are two separate cars. 10 talks about this car, 6 talks about this car. We don't ever want it to happen to where this number gets updated, 8, or we change the primary key, and it's still referring to the same exact car because then we have a changing primary key. But with foreign keys, it can change in the sense that, oh, I no longer own this car, now I own this car. So, we didn't have any primary keys updated, but the foreign keys, which would be this connection right here, did update, alright? So that kind of is a little bit of a difference between primary keys and foreign keys. Primary key values should never change. Foreign key values can change because references change. Hopefully I didn't just lose my train of thought. I think I'm going, but kind of hitting a blank here for a sec. Okay, so let me just illustrate this in a college, right? One of the important things between these tables that have a primary key and a foreign key connection to that primary key is that they have to be of the same data type, which is the type of data, whether it be int or character or date, and basically it has to have all of the same characteristics like the collation or the character set or the storage engine. Now, the only thing that can vary is the not null characteristic. Because if we have the primary key over here, well, we know that the primary key is never null. So we always have not null for the primary key. I'll just put NN for short. The foreign key, on the other hand, it's not always required to have a connection. For example, in that previous example, we had the user table, we had this guy over here, and then we have this car table of the cars that the user owned, right? He could have one car, right? Well, he might not currently own a car, therefore we don't have a connection to this table, therefore this connection is optional or not required. Yeah, that doesn't even look like English, but close enough. So let's think of another example. If we have a college, well, we might be early in the semester where every single class, before people have registered, every single class doesn't have an instructor yet, and we're still trying to find an instructor, although we know that's the class that we want to have. So that means we have an instructors table, we'll have the instructors over here, and we have a class table. Well, a class table is going to have a foreign key pointing to the instructor for the instructor of that class. Unless the case of a many-to-many where multiple instructors can teach multiple classes, then we would need an intermediary table. But that is not the case here. If you need to learn more about that, check my relationships video. But for now, we would have a class ID and an instructor ID. Right? And then over here we have an instructor ID. As it says INS, instructor, close enough, right? Now, this is going to be a reference to this over here. Now, what kind of values is this going to accept? Let's give some examples. Let's say we have, here's a row, we have the class ID 7, the instructor ID 83, and we'll add a column, we'll make it the name of the class. We have a column and it's math. Right? And then we could have another value within here. I think I'm off screen now. Then we could have an instructor over here. His name, his ID could be 7, and his name could be Jake. Right? So this class ID is 7. Yeah, let me change this, it's going to get confusing. Let's make this 16. Alright, so this class ID is 7, and it's by an instructor of 8, which we don't actually have over here yet. So that means we either have another row or we have an error, because we never want that to happen. So let's say we have another class. Got any room? Okay, we have another class over here, and its number is 8, and it's taught by Caleb, right? So now we have an instance of a class. We got the class ID 7, the instructor ID 8, and the name math. So the instructor ID points to this instructor over here. This is the parent. I'm sorry, this is the parent. This is the child because this is a foreign key reference to the parent. So that means this relationship is a foreign key. Now, with the not null thing, if we made it to where it's not null, if we added the characteristic not null, well, that means this row is going to have a value for the instructor ID. That means every single value for instructor ID is required. What does that get rid of? That means it's impossible to put a class in this table that does not have an instructor ID. That could cause a problem if you have a class created but you don't have an instructor yet, or if the instructor drops out and you have to find a new one. So this one might be a bad time to use not null. If we got rid of that, well, now we could have a class with a primary key but no foreign key connection. Now we have a class with the ID of 7 and it's meth, and the current teacher, we don't have one. And we still have this guy over here. He's not teaching that class, but he's still in the system. Jake's still in the system. The class is still in the system. That is a good example. So for this one, not null might not be the best idea. Other examples, having not null would be a good idea because it forces that relationship to be there. Here, let me think of another quick example real quick. If we had two entities, we had a card for a credit card company. So we had the card, and then we had the person holding the card. So the person who bought the card, or was getting the card from the bank and is using it to buy their groceries and their gas, and they're ranking up thousands of dollars in debt. Well, that person would have a relationship with this card because he's the card holder. That's the card. Now, if we had a table for this, we'd probably have a card table, and we'd have a person ID, which would reference the person table, right? If we set this to not null, that means every single value or every single row within this card table is going to require a card owner. If we got rid of this, that means we could have cards in here that were outdated, that don't currently have an owner because there's no connection, we broke that owner, or new cards that haven't been given out yet. So if you want this table to just be for cards that currently have an owner, so we could have owned cards, well, then we could have a not null column with the same data type as person ID. And now every single value is going to have a person ID. Does that make sense? So that's kind of the introduction of not null and how that works with foreign keys, and how sometimes you will want them to be not null and other times you want them to be nullable or not required. I got a bunch of writing on the board, but don't look at it yet because I just want to talk to you guys for a minute. I just wrote it so you wouldn't have to watch me write like 50, 100 words, because that'd just be boring. So instead, I'm just going to talk instead. So much better, right? Anyways, last video and throughout the series we've talked about foreign keys. And as we know, they keep connections between tables in a database. So table 1, table 2, boom, foreign key. Connect from this foreign key references the primary key of this table over here. That's kind of how foreign keys work. They protect the integrity of our database. They keep everything consistent. Think about if there was no foreign key constraints, which keeps it updated and everything, then we would have to manually update all connections between tables. And that'd be a big waste of time, and it'd just be easier just to store everything in one giant table, which both solutions, either manually doing it or storing everything in one giant table, is not going to work. So we need foreign key constraints to protect the integrity of our database, right? It's called referential integrity. That's a big word, sorry. Alright, so now, this concept, these words, might be specific to a certain relational database management system. So these are from MySQL, but if you're using a different relational database management system, yours might be a little bit different. But in general, the concepts are pretty similar, so you're not wasting your time if you don't use MySQL, because you need to understand how foreign key constraints work. Alright, cool. So first of all, foreign key constraints, make sure that if you update the parent, the children are going to update or cause an error or something like that. It's up to you. You can make the decision. And it's also going to prevent you from creating children when there's not a parent that with that primary key. For example, if we have 5 users with the user's ID 2, 4, 6, 8, and 10, and then I make a comments table and I add a row that's like from the user 745, well, that person doesn't even exist, so that's not going to work. So that's why foreign key constraints are important, because they, once again, protect our database and make it pretty much self-managed rather than us having to manually update everything. So let's begin. Alright, let me get a piece of chalk. This one looks nice. I'm getting pretty low. This is the biggest piece of chalk I have left. Alright, so when we create an SQL statement, we can add these two keyword phrases here, on delete and on update. This refers to the foreign key constraint. So but it's talking about the parent. So when we update the parent, we want get away, you stupid fly. Alright. When we update the parent, we want the children to do something. When we delete the parent, we want the children to do something. That is what these keywords mean. So these keywords, it's talking about the foreign key constraint, and it refers to the parent. Alright, so let's just draw some basic tables just to kind of keep things. I'm not going to give any specific examples yet. I'll just kind of draw things out. So let's say we have a parent here. And as you learned in previous videos, the parent is the primary key, right? And then let's reference this primary key with a child. Okay, let's not draw this line yet. And then we have a foreign key. This primary key is a column within the parent, and every single row has a unique value. The foreign key is a column within the parent, and it references the primary key. So the value 400 in a row could reference the value 400 in this row, in a row of this table. You get it. I've explained it enough. Now let's just make another child table. So these are both foreign keys that reference the same primary key, but they're two separate tables. So yeah, like we could have a user table, and then we could have a comments table and an orders table, for example. They both are bought or commented by a user. So these foreign keys reference primary keys. So every single value within the table of the children, within the foreign key column, needs to be a value that is present in the parent column. Now, these values right here, these options, refer to the parent. So when we delete the parent or when we update the parent, we want the same thing to happen to the child, or whatever the options are, and we'll talk about the options in a second. So that's kind of how these work. Now just to kind of clear things up, I'm going to erase these words here, just because it's getting a little crowded, you know? I want it to be peaceful. Alright. Okay, so this is kind of how it's working. Foreign keys point back to the primary key. These options refer to what happens to the parent. Now these options right here, these refer to what happens to the child. Okay, now it's getting real confusing. There's arrows everywhere and like graphs and diagrams and whew, but you'll get it, don't worry. Restrict, you might also hear it as no action, is, well, at least for MySQL, in different database management systems, these might be different. But anyways, restrict is going to throw an error. So if we try to, like, we can give one of these for each option. So on delete, we could either give restrict, cascade, or set null, or null. on delete, we could have it restrict, cascade, or set null, just to add more arrows, you know. But let's say we're working with delete right now, and we want to use restrict. So within our SQL statement, we could say on delete restrict. So on delete restrict, and that is going to give us an error whenever the parent is deleted. So if I tried to delete the user with the ID, I don't know why I'm writing all that out. Let's just say the ID of 504, and then this child has a row that has 504 within the foreign key column, well then it's going to throw an error and it's not going to happen, and the parent will not be deleted. Not going to happen. So that's how cascade on delete works. I'm sorry, restrict on delete. Now restrict on update, if we updated that parent and changed their primary key, so let's say we changed 504, and these children both reference 504 with the foreign key, and then we change this to 508, and it's not going to work, and it will go back to what it was originally. Because we have it restrict. We're not going to let that happen, you see? Alright, what about the next option? Cascade. Cascade will do whatever we do to the parent to the child. Let me clear this up a bit, this is confusing me. Alright. Just smearing chalk all around, you know? Totally helping. Alright, so now if we cascade on delete, that means if we delete the parent, we're going to delete the child as well. So we delete 504, and boom, children are deleted, boom, child deleted. So now 504 doesn't exist at all. So like for example, if this was a comments table, and we had a comment from the user with the user ID of 752, and we deleted 752, the user, well then obviously all of his comments by him should be deleted too, because we'd have a comment by a user that doesn't exist, which isn't supposed to happen. So cascade on delete would do that. On update is if for some reason we updated the primary key, which obviously shouldn't happen because primary key should be never changing, but you still want that protection on your database. On update, if we have cascade, if we change like 504, let's say these people exist again. I'm just going to erase this because I don't, oh yeah, okay. So these people exist again, 504, 504. These references 504. And if we update this to 508, well that means all of the children will update as well. So now it connects within different tables. Finally, we have set null. And what that'll do is it will basically just set the children as null for that specific value. So if we deleted the parent, this is just going to get rid of the value. The row should still exist, but the actual foreign key reference, it no longer references anything. It's empty, so it's not referencing anything. So the column for that row, so like let's say we have a comment, and it's a comment from Billy Bob with the ID of 504. If we delete that, well now we're going to have a comment with no poster or no commenter at all. It's just no value. That's what set null will do if we use on delete. On update, same thing. If we change the ID of the parent, changed it from 504 to 508, well all of the children are going to be set to no value as well. Alright, now there's one important thing with set null. The children have to have, they can't have, I should say, the not null characteristic. We talked about that in previous videos. I'm just going to put NN for short. If this is not null, and we update, if we have on update set null, and we update 504 to 508, can you even, have I been cutting this off this whole time? Alright, we set 504 to 508, I think you can see that one. Yeah, you can. If we change 504 to 508, and this is not null, it's going to be like, we can't do it because we can't set it to null, because it has the not null characteristic, which means every single row has to have a value for that attribute or that column. So it'll give an error, and it'll go back to how it was. So that's an introduction to foreign key constraints. Sorry if I talked fast. But yeah, cool stuff. It's important stuff, so learn it, study it, and learn it for your specific relational database management system. In this video, we'll be talking about simple and composite and compound keys. These are categories of keys. So like when you define a database, you can say, alright, this is a primary key, or you can say this is a foreign key. But you don't have to say, oh, this is a natural, simple primary key. Like those are just categories, you don't have to define that within our database. So these terms that we're learning are more for design's sake, so you know the best design for your database, but you don't actually have to define it, right? Like for example, this piece of chalk right here, you can define this as a white piece of chalk. Now what kind of white piece of chalk is it? Well, it's X brand or whatever. You don't have to define that when you're telling someone, oh, here's a piece of chalk. That was the worst example ever. Moving on. Alright. Simple and composite. Okay, so simple means that the key consists of one column. Composite means it consists of two or more columns. This is most common with natural keys because natural keys can be a combination of multiple columns, whereas a surrogate key is just a random number, one column. So surrogate keys are simple. Composite keys are multiple columns. So for example, we could have a first name plus last name plus email. This could be an example of a composite key because this whole group as a whole is the primary key. So we could have Jim, Jake, and legit or awesome at whatever, just blah 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 blah. And then we could have another one with the same exact name, Jim, Jake, and we could have a different email. Well, these two are still separate, they're unique because the combination of the three are unique. Jim and Jake repeat, but the email is different. So these as a whole are different values for the primary keys. So that's an example of a composite primary key. The reason is because it consists of three columns. 1, 2, 3. This is an example of a composite key. A composite natural key to be specific because we're using things that are already naturally being stored within our database. Now let's think of a simple key. A natural one, or a username would be a good one. Because the username can be something that can be used by itself as a key. It's simple because it's only one column. Pretty simple, I know. Huh. Alright, so I want to talk about another term you might run into. And that is compound. Okay, now, I want to clarify that some people and some relational database management systems don't clarify the difference between these two, composite and compound terms, and they just use them interchangeably as meaning a key with multiple columns. Some people go a step farther and break these up into two separate terms. So we're going to be defining both of the terms, but you might see them used interchangeably. So don't be so super technical about the details, and don't be like correcting people, oh, hold up, that ain't a composite key, that's a compound key. Duh. Because most people are just going to look at you like you're an idiot and not really care. Alright, so anyways, moving on. A compound key is basically when it's a key that has multiple columns and they're all keys themselves. So this is the most common example of this is for intermediary tables. So think about it like this. If we have a table used to store information about videos, we could say it's a video table. We could also have another table over here. We could have a user table. Actually, here, let's do it this way. We're going to have a comments table, okay? And then within this comments table, we could have a column of what video they're commenting on. You see, well, this is a many-to-many relationship, right? So, this might not work out well with database design because one user can comment on multiple videos and then one video can have comments from multiple people. So the best way to do this, rather than having two separate tables like this, we would create video table, and then we'd have an intermediary table, and this would be video comments or user comments. You see what I'm saying? So we get a connection between the user and the video to create an intermediary table, and it's split up with two keys. So we have the user ID and then the video ID, and then we could have another column for the message or the date or whatever else. Well, you can see, if you don't know what I'm talking about, go see my videos over designing many-to-many relationships. But otherwise, if you do know what I'm talking about, moving on, you can see that the entire key itself, every user and video ID combination has to be unique. That might be a bad example because a user could comment on the same video more than once. So this is probably not the best example. Let me think of a good one. But anyways, this would be an example of we could add another column in here to make it unique. We could have the date and the message. So the message has to be unique, and the user ID has to be unique, and the video ID has to be unique. That would be a composite key. A compound key, let me think of an example real quick. So a good example of this would be for college. We could have a student table, and we could have a class table, right? So this table holds information about the student, this table holds information about the class. Now how do we show enrollment? Should we make columns for every student here? No, because it's a many-to-many relationship. That means we need an intermediary table between the two. So this is a good example. Sorry about my bad example in the last one, but that's a good example of a composite key because the two columns themselves wouldn't be enough, so we'd have to add another one, which is not a key in itself. But for this one, we could have a column. We'll name the table student classes, or just student class, whatever you want to call it. Student classes, and within here we could have the IDs, student ID, and class ID. Now, this combination between student ID and class ID must be unique. So let's say we have the values 7 and 4, 7 and 6, 7 and 7, that would work. But if we had something like 7 and 4 again, we would get an error because that's already in there, and that's not going to work out so well. So the combination has to be unique. And these are also both foreign keys, which point to another table. So both of them are keys, and the primary key is compounded because we have the student ID and the class ID as one giant ID, or one giant key, I should say. Because the combination has to be unique. We can repeat 7 on this side, and we can repeat like 6 on this side, but we can't repeat the combination of 7 and 6. They have to be unique as a whole. So composite keys, that's when you have at least one is not a key in itself. For compound, they all have to be keys. So for the composite, let's look back at the example we gave in the last one with the videos, the video comments. Let's say this is the intermediary table blown up just so we can see it real big. This is the user ID, and then we have the video ID. Well, this isn't sufficient to make uniqueness because a user could comment on the same video more than once. Like if you're replying to comments or something like that. So we need another column. We could add a timestamp, or we could just say the time column. And this is going to keep a unique time because you can't comment on the same video at exactly the same time twice. Right? So that would ensure uniqueness. So we can ensure these three as a whole are unique. That's an example of a composite key because at least one column is not a key in itself. This is a key because it points to a users table. This is a key because it points to a videos table. This is not a key because it's just a column for that intermediary table. So those are the 3 terms I wanted to talk about in this video. One other thing I wanted to talk about real quick. I'm not going to say what the best technique is for this. I'm just going to say what some people do. With an intermediary table, some people will give it a surrogate key on top of the compound key. So for example, with the college, keep switching back and forth between examples, I'm probably confusing you. They might add something such as enrollment ID, and then we have the student ID, and then we have the class ID. These are both foreign keys, and they might use this enrollment ID as a just a surrogate key for this table, although it's not a requirement for certain relational database management systems. Some relational database management systems or frameworks or something are not going to be able to work well with composite or compound keys, so you might need to have a simple key, which in that case you could still have the idea of a compound key. This group right here, the student and the class, you can have that indexed or whatever you want, or you can just enforce uniqueness with that. But then you can use an enrollment ID, so you could have like 7, and then you could have student 6 in the class 4, and then you could have 8 with the student 4 in class 12, and then you can have 9 with the student 16 in class 4, and then we could have 10 with student 16 in class 12, and so forth. That's just an example of what some people do. This video is just going to be a quick review. I'll actually be using my notes here just to make sure I get the main everything, because I'm not going to try to memorize like 10 videos of content. That's just crazy. Crazy, I tell you. Alright, but anyways, first thing we started with was super keys. So a super key was just any number of columns that ensure uniqueness within a table. So we have super key, which I still don't know why that's only one word, which just confuses the heck out of me, so someone please explain that. Then we had a candidate key. Now the difference between a super key and a candidate key is that a candidate key is the least number of columns used to enforce uniqueness. Now you can have multiple candidate keys if you like a certain group. So if that's the case, you have to pick one as your primary key. The primary key is the one you select as the main key for your table. All the other ones you can assign as alternate keys, which if that's the case, they still can be unique. You can still enforce uniqueness upon those, but they're not used as the main key within your table. Alright, what else? Alright, well then there's, that's pretty much all the ideas with finding a primary key, and then when you reference that in another table, you have what's known as a foreign key. Foreign keys reference a primary key. It's a connection. That's how you make connections between tables. If you have a user table and then you have a comments table, well, the comment is posted by a user, so you can reference that user in that comments table. And we talked a lot about that, so I'm pretty sure you guys got that pretty well. Now, this is pretty much all you got to worry about for primary keys and foreign keys. You just got to worry mainly about these two. These ones are less important about finding and figuring out. These two are essential. I'm not saying these aren't important, they're important, but really, defining a super key is kind of pointless when you know there's the candidate key. You don't have to say, okay, well all of these define uniqueness. That's one super key. All of these define uniqueness. That's another super key. Oh, finally, we're down to the correct size for a candidate key. That's our candidate key. And then I'm check marking, by the way, just so you know what that is. And then, oh, okay, we got a total of 10 candidate keys, 5 super keys. Now let's find a good primary key. Oh, this one looks nice. We'll use that one. We'll set the rest as alternate keys. That's just complexity that is unnecessary when it's easier just to say, oh, there's a candidate key. It's already the smallest that we need. We'll use that as our primary key. And now let's see if we have any other alternate keys. Oh, we don't have any good ones? Oh, too bad. It's fine. Who really cares? Oh, we do have some good ones. Oh, yeah, let's set those as an index and make sure they're unique. And we'll use those for some searching later on. That's an example of how you would find a primary key. You don't have to make this manual labor for like 20 hours to figure out which primary key to use. Alright? Then you reference that primary key in other tables with the foreign key. So that's why these two are the most important. Foreign and primary. Those are the two you should focus on the most and memorize, okay? The alternate candidate super key, and they're kind of important, but not as important. Alright, so let's take a look at primary and foreign. Let's just, let's clear this out for a second. Oh my god. Alright. Primary. Now there's some categories. Dude, I dusted, and now it's like, whew. Can't even breathe. There's some categories of keys that we can talk about. So the first one was surrogate and natural. So surrogate and natural keys. A surrogate key is just a random number that has no real world value or no real world meaning. Just like an ID, user ID, student ID, college ID, classroom ID, store ID, sale ID, record ID, song ID, picture ID, whatever you want it to be, I don't really care. As long as it's an ID and it's a surrogate key, then yay. I don't know what I just did there. But anyways, natural is something that's already naturally in the database, and you just define it as your key. Now typically when you want to use keys in your database, which you will because it's your relational database, you will pick either surrogate or natural keys and you'll use them throughout the rest of the database. You're not going to switch from surrogate and natural. You're not going to be like, oh, this one has a natural key, we'll use natural, but this one doesn't, we'll make it surrogate. That's a bad design. You should be able to enforce uniqueness by the columns that are already there, and then you can add a surrogate key if that's what you want to do. And if by any chance you cannot possibly define uniqueness without a surrogate key, you're pretty much required to use the surrogate key. But that situation should try to be avoided. But there's times when you literally cannot find a natural key that will be sufficient. So you guys kind of follow what I mean. Surrogate keys, random numbers, natural keys already in the table. Boom. Simple. Alright. Speaking of simple, we'll talk about the simple key. Alright, so we got simple, we got composite, and compound. Okay, so simple is basically a one-column key. Composite and compound are multiple column keys. We talked about those in the previous video, I believe. Yeah, so that's pretty much all the categories of keys. When you define your primary or foreign keys, you're not going to have to specify if it's a surrogate, natural, simple, composite, or compound. This is for our sake to design the best way. Because, for example, do you want to use composite keys or do you want to use simple keys? That's a good question. If you decide you want to use simple keys, which, by the way, surrogate and natural is kind of thing you do throughout your entire database, you can kind of switch back and forth from simple and composite. For example, you could have a users table, and we could have a students table, a class table, and then we could have an enrollment table with the students taking certain classes. We could use I guess we could use a compound for this table, and then we could use simple for these tables. That's something you could do. But you should still use either surrogate or natural. Just pick one and use it throughout your database. Hopefully I'm not talking too fast because I'm going pretty quickly. If I am, just let me know. I just need to calm down a couple decibels because I'm kind of hyper. Okay. No, the other thing we talked about is foreign keys and foreign key constraints. Well, the main kind of foreign keys, constraints were on update and on delete. These protect our integrity of our database. You define these whenever you make a table. When you use the create table statement or create or whatever your relational database management system does to create tables, the chances are you're going to say that you have a foreign key. I'm just going to put FK for short. And then you have a constraint, and you can usually name that constraint So you could be like blah blah blah, name it whatever, and then we could say on update or on delete. And the options were, the ones I taught you were do nothing, or basically throw an error, or we could update the children, or we could basically get rid of the value for the children. So that would be restrict, cascade, and set null. But your relational database management system might use something a little bit different, which is fine. Yeah, that's about it. Yeah, that's pretty much it. Yeah. Cool. Alright, so yeah, that's a summary of keys. So yeah, that was a ton of stuff. Okay, so there's a couple different names for this. So basically, it's just a standard. It's a standard for drawing databases. And the couple terms you might hear, or acronyms I guess, EER model, ERD, or ER model, or just database design, whichever one's easiest. But basically, these are some terms used to refer to a method used to draw out your entire database structure. These videos I've been drawing tables and lines and drawing tables and lines and stuff and all kinds of cool things like that, but actually I haven't officially designed any database. So what we're going to do, now that we've learned most of the concepts, the only thing we haven't really covered is normal forms, which we'll be getting into those, but anyways, and I'll make them easy, don't worry. So what we're going to do is we're going to learn the standard for drawing these databases. We're going to practice with that, and then we're going to learn the normal forms, and then we're going to design databases. It's a lot of stuff, but we're going to do it. So we're going to be getting into the standards of drawing databases, and obviously the standard's kind of rough. I mean, there's not a specific way you have to do everything, because that's annoying and dumb. So what we're going to do is we're going to be drawing pretty simple things, and I'll just be kind of illustrating kind of how that works in this video. So what this means is enhanced entity relationship model, enhanced relationship diagram, enhanced relationship model. Yeah, I think that's what they stand for. I don't think it stands for relation. I think it stands for relationship, which there is a difference, as you should probably know by now. A relation is a table. A relationship is a connection between two tables. Yeah, so anyways, yeah, so we're going to be talking about these designing techniques. I'll probably just call them like ERD or EER, or who knows what I'll call them. But yeah, the way you do it is you define your database structure. So anything that is DDL, pretty much. Data definition language, part of SQL. We talked about that a long time ago. We're not going to define the actual values. For example, if we have a table for users, we're not going to put in a row, oh, Caleb Curry with the password of sweet pie is delicious 24, and the email of yeah@yeah.com, and the telephone number of 1-800-YOU-WISH, or anything like that. We're not going to put anything like that in there. We're just going to put the columns, username, password, email, telephone. 3D. That is so cool. Okay, anyways, let's get started. So to draw a table, a database table, you just draw a square. It's like super easy. Okay. Wow. Who would have thought it would have been so easy, right? And obviously, doing this on a chalkboard is not very convenient because, for one, you're limited in space, and for two, most of you guys don't have chalkboards, and for three, I don't know a third reason, but most of this is actually done on a computer, and we will be doing that hopefully soon. So, stick with these concepts we'll be getting into on the computer design for whatever reasons, and obviously as I make new videos in the future, that's what I'll be doing. So for now, we'll learn the concepts, and you can download entity relationship design programs such as MySQL Workbench. I made other ones like Vertibello or something, I don't remember what it's called, and a couple others which you can design for any relational database management system on that one. So go check out my other videos, or my playlist. I think it's under reviews or something. But I don't know. Look up database design on my channel, see what I got. You can also just look up EER or ERD relationship or design, and you can get all kinds of apps and programs to help you design your databases. And then some of them have what's known as engineering, so you could forward engineer your database